Hi, everyone. Today, what we're going to go through is another factoring review. However, today's stuff is going to probably challenge us a little more than yesterday. That's not to say that last time wasn't challenging. However, today we're going to look to extend some of the factoring that we've done in the past and probably introduce some new styles of factoring today. So, what I want you to see on the screen, that is going to be every factoring problem that I'm going to throw at you for today. And I almost want today to act like a challenging factoring review. Like we should be able to use this as almost a little bit of a practice quiz, if you want to think of it that way. A chance for us to have a bunch of different things thrown at us and just to see how we can kind of stumble our way through. I'm going to argue that a lot of today is probably going to feel like the tougher end of factoring expressions. But we can use those as an opportunity to challenge us in terms of problem solving. So what I would like you to do, keep this screen on, pause the screen so that you have every problem that you can see, and I want you to work your way through each one of these problems. Feel free to skip over problems if you get absolutely stumped and have no idea where to go next. But every problem we should have an attempt to. That's the goal today. So when you take a look and you see that you have 8 problems that we are going to go through, I want at least something down for every one of those 8. But please feel free to jump around and skip over one and come back to it afterwards. When you are done pausing the video and attempting all 8, then we're going to go through solutions to each one of them. So with each one of those solutions, we're going to make the assumption that you have something down, and then we're going to kind of build from there. Okay, I want you to attempt these 8. Good luck. Pause it now. Okay, we're back. So you'll see the first 3 problems on your screen right now, and I'm going to add kind of some commentary for these 3 that I think that these 3 problems should have been 3 of the easier ones that you tackled today. So pretty quickly, we should be able to go down our factoring checklist, that decision-making tree, and we should be able to argue our way through all 3. The first one, I have 3 terms. First thing I always look for is a common factor, and I notice that in each of those 3 terms, I have at least a 2 and an x. So I'm going to factor out a 2x from every term. That's going to leave me with an x to the 4th in the first term, my 7x squared in my second term, and a positive 10 in my last term. Now I take a look one more time and I see, does something factor further? And I notice that I have that common trinomial, I should say that special type of trinomial, although it's common for us, where my middle term is a single something, my lead term is a squared something, and I have a constant on at the end. So I shouldn't be fooled by the fact that they're x to the 4ths and x squareds. I'm looking for 2 numbers that multiply to give 10 and add to give 7. That would be 5 and 2. I just know that my leading term has to be x squareds now, so that they would multiply to give me my x to the 4th, and so that their middle term would be x squareds. There we go. So hopefully not too bad. If we struggle to at least pull out the common factor, I would be a little concerned. If we didn't quite know how to address the x to the 4th situation, then I wouldn't be overly concerned about that, but that should be something that we should be looking for when we factor. We should have had that one. Okay, let's jump in and take a look at B. B, I've got 4 terms in my expression. First thing I always look for is a common factor, and I notice that there is not a common factor in all 4 terms. So my next option might be, let's see if I can factor it by grouping. So if I try grouping 2 and 2, then I do notice that I have a common factor of A in the first 2 terms. And once I factored out that A and I got a factor of B plus C, I'm trying to factor the last 2 terms so that I get the same factor. That's what motivates me to factor out a negative D from the last 2 terms and not a positive D, because that will leave me with a positive B and a positive C. And now on that blue line, I have two terms. Both of those terms have a common factor of b plus c, so I'm going to factor that out. I'm left with an a from the first term and a negative d from the last term. There we go. So hopefully B was pretty straightforward. That's kind of a standard factoring a four-term expression. You come in on C, and C should have been the easiest one of those three. I have two terms. The first thing I look for is a common factor. There is not a common factor. So the next thing I'm looking for is it a difference of squares? And yes, it is. Because 4n squared is just 2n times 2n. 25 is 5 times 5. And I know if I factor a difference of squares, then I have to get conjugates. There's my two terms with the exact same terms inside, but different signs. And there we go. So hopefully those three we nailed out and we felt relatively confident. Okay, let's jump into the next group. Now, you take a look at what we have on the screen right now, and I'm hoping that these ones went relatively smoothly. What I'm going to do is I'm going to introduce like a methodology for us to be able to factor these if we can't recognize right off the bat what we have. Like, I would love it if when we took a look at D, we could see in D that I have one term, another term, and another term, that's really just a trinomial. I have three terms. And we would be able to factor that as a trinomial. I'm really hoping if you take a look at E, we recognize that we have two terms. And so we have some strategies to be able to factor two-term expressions. That binomial should have been okay. However, because each of those, the trinomial and the binomial, look a little uglier, a little more complex, we may have another strategy that we might like to use. If you are struggling to see that D is just a complex trinomial and E is just a difference of squares, then I want to introduce you guys using substitution as a strategy. This isn't a strategy to factor, it's just a general strategy to try to simplify the way something looks. So let's take a look at D right now. If we notice that we have this A plus B that pops up, and I see it multiple times, then one strategy we can use is we can use substitution to try to simplify the way something looks. So what I could do is I could let anything else, just not an A or a B, but anything else, like maybe an X, be equal to that common expression, A plus B. And if I create that let statement, then that's what allows me to change that expression into a 6x squared plus 17x plus 5. And now we should be able to see that that's just our complex trinomial that we factored last time. So we could pretty quickly break off, deal with our fast factoring, and factor that expression. Hopefully we could then see that when we factor that, we would get a 3x plus 1 and a 2x plus 5. That would be our expression. Here's the problem, though. I never asked you to factor an expression that included x's. So what we would now have to do is go and sub back in an a plus b wherever we saw x. That would then allow us to go through and say, okay, what we then have is 3 times a plus b plus 1 and 2 times a plus b plus 5. Now, hopefully we can see that that's factored. It's not fully simplified. We'll address that in a moment. However, What I would love us to do is to have the ability to skip over all of that stuff and come right in on the green line. So what I want to do is I want to get rid of substitution, which then means that we don't have to resubstitute. We want to be able to see the green relationship in the original expression. So what I'm going to do is I'm just going to erase a bunch of that stuff. You pause the video and get down whatever you need to. You have that ability. But I'm going to erase all of that. And I want to tackle this right from the very beginning. So look at my blue underlines again. We recognize that we have 3 terms. We also recognize that I have a squared something and a single something and a constant. Now, because my leading term is not 1, then that's just my complex trinomial, and I can factor that using a fast factoring method. So I'm just going to get rid of all my circles because that's what identifies the form of that expression to me. As soon as I realize I'm going to use some fast factoring, then I can jump up and I can deal with my fast factoring chart. Okay, 2 numbers that multiply to give 6. Now jump over, 2 numbers that multiply to give 5. And if I multiply across, then that is a positive 2 and a positive 15. That can give me my 17. I have it. The only thing I need to do now is I need to put in my brackets and my variable. Well, we should be good to be able to start off with that in our brackets. Last time, our variable was an X or an M or an A, so we always knew where to put that variable in. Well, nothing really changes here. What was my squared something? What is my single something? It's A plus B's. So, put in your A plus B's. Notice if I was just to expand the first term inside each bracket, then there is my 2 times 3, 6. A plus B times A plus B is A plus B squared. So, I don't actually write it that way. Up in your chart, you can see that really all I need to do is, okay, so I have 2, put in my variable, plus 5. And then 3, put in my variable. It just so happens that my variable is now a variable expression in this case. Okay, we get down to that and we're almost done. Our only issue with what we have inside those brackets is it's not fully simplified. Like, take a look at that first factor, and we could simplify that further. So let's go ahead and expand in our 2. Let's go ahead and expand in our 3. And now we have fully simplified factors for that expression. Okay, just so that we can understand what I'm asking you to do there, the equivalent would be if I gave you, I don't know, a number like 15, and I asked you to factor 15. Well, I would hope you would tell me like 5 times 3. I would really hope that you wouldn't tell me 4 plus 1 and 2 plus 1. Like, you wouldn't give me the gold factors, because what you would do is you would simplify 4 plus 1, and you tell me 5. You would simplify 2 plus 1, and you tell me 3. That's kind of the equivalent up here. Don't give me something unsimplified. Simplify it. And hopefully that kind of makes clear the expectation. Okay, let's jump into E now, because I'm going to bet that even though we may have struggled through E the first time through, we might be a lot better with this now. That is, you take a look at that expression, and we're not that thrown off by that A squared plus 2A anymore. That we can see that we have 2 terms. Well, one of the other ways that we can use substitution is that if I have a multi-term expression, then maybe what I can do is I can just go through and let a single variable equal a multi-variable expression. If I did that, then I come in on this, and now x squared minus 64, that should be screaming at us as a difference of squares. But I'm not going to go through that same process because we're a little bit better than what we were 5 minutes ago. So if we recognize that what we have is a difference of squares there, then let's factor it. So when I factor my difference of squares, I know I get conjugates. The same thing inside my brackets, different signs in between my terms. So maybe I say, okay, well, what was squared to give me my first term in my original expression? What was squared? Well, it was an a squared plus 2a. So that goes at the front of both brackets. What was squared to give me 64 in my original expression? Well, that would be an 8. And now if I'm going to change those into conjugates, or factor it into conjugates, I should say, one has to be a plus, one has to be a minus. Doesn't matter which one you make which. So we come in on that line and we should be good. Just don't relax too quickly. Remember, every time we factor something, we got to take a quick peek and see, can we factor further? Well, you look inside the first factor and we see we have a trinomial. There's a simple trinomial, so I need two numbers to multiply to give 8 and add to give 2. There aren't any of those. So that is fully factored. However, in the second trinomial, two numbers that multiply to give negative 8 and add to give 2, I can factor that second one further into a plus 4 and an a minus 2. Okay. Hopefully that went pretty well, or at the very least, we can now start to see that really all we're dealing with when we get into more complex expressions is we're dealing with some puzzles. That we actually have the tools with us to be able to factor all of these. It's just a matter of, can we see it? And are we testing our strategies, fully exhausting them? Okay, if this doesn't work, then I try the next thing on my list. If that doesn't work, I try the next thing on my list, and so on. Okay, let's jump into more of those problems. Okay, now let's take a look at F and G on the screen. I'm going to argue to you that I think F and G would probably be the two most difficult ones that we've covered today. Like, I'm going to throw F into probably the most difficult, and G can cause a real problem with something. So let's focus in on F. We'll leave G for a moment. This is the way we should have been thinking about F. So I want you to compare the way I'm going to talk out loud about F with the strategies you tried. Okay, in F, I have 4 terms in my expression. The first thing I always look for, a greatest common factor. I look across, and the problem is I don't have a common factor in all 4 terms. So I try to group. And my first instinct might be I'm going to try to group 2 and 2. If you started off that way, then I think you have great instinct to factor. I do. However, I want you to see that the way I'm going to factor this 2 and 2 is not going to work out well. I need to show you this because a lot of us might attempt this, and we might think that we've done some good work to the point where we think we're done and we move on to the next problem. I need you to see why what you may have done is not factoring. Okay, let's take a look at F. I'm going to factor it 2 and 2. I look at my first 2 terms and I go, hey, that's a difference of squares. And a difference of squares factors into conjugates. So when I factor a squared minus b squared, I can get a plus b times a minus b. Okay, now I look at my last 2 terms. Well, the first thing I look for is a common factor, and I notice that I have a common factor of 8 and a c. There's an 8 and a c in both of those terms. So if I factor out an 8c from the first term, I'm left with b. And if I factor out an 8c from the last term, I'm left with a negative 2c. So we get to that point, and maybe we're not sure where to go next. Maybe we think we're done. Let's imagine we move on to the next problem. I need you to know that if that was your factoring attempt and you provided that on an evaluation, that would earn nothing. Now, you might look at that and go, really? Like nothing? Why? What's wrong with that? And we need to clarify together why that is not factored at all. Now, the hard part is you might go, but it is factored. Look, I factored. And I need to be very clear here that what you've done is you factored parts, but you didn't factor the expression. I want you to look along that blue line and notice I have that plus in between there. That tells me that I have one term added to another term. That means it's not factored. I'm adding two things together. Factoring means multiplying those things together. So I want us to make sure that we're good. And this might seem like a weird kind of scenario, but again, I just want to make sure that we're good. This would be as if my beginning expression had a value of 34. Okay, imagine that beginning had a value of 34. So I ask you to factor 34. And what you're going to tell me is that 34 is 2 times 3, I don't know, plus like 4 times 7. Like you're going to tell me that 34 is 6 plus 28. And yes, I would agree with you. 34 is 6 plus 28. But if you were to factor 34, you wouldn't factor it into 6 plus 28. But that's what we've done in the blue. You've taken an original expression and you factored it into something times something plus something times something. And that's not factored. So it is so tempting for us to go through and deal with factoring that expression in that way that it happens so often that I need to make sure that we don't think that that blue is factored. It is not. So make sure that that addition sign is screaming at you, that that is not done. Now, your next question might be, well, then what do I do next? And I hope that we can see that I can't factor that expression that way. That me trying to group it 2 and 2 will not create a scenario where in the first 2 factored and the second 2 factored, that there will be a common factor where I can factor further. Unfortunately, that strategy didn't get me anywhere. Okay. That means I'm going to get rid of everything that we just put down there. I'm actually going to get rid of my underlines too, because I realized that factoring 2 and 2 did not help me. So where does my strategy take me next then? Well, if I can't get anywhere trying to group it 2 and 2, then maybe I take those 4 terms and I group it a different way. Maybe my strategy then is to group it 3 and 1. Now, you look at those 4 terms, and if we're going to group it 3 and 1, that means you have to pick one term that you're going to get by itself. That is, one term in that expression has to kind of jump out at you. And I'm going to argue to you, there really isn't a bad way to look at that expression. I call that expression kind of like my Sesame Street problem. And if any of you guys grew up watching Sesame Street, which I hope many of you did, they used to put on like a little segment that was called like one of these things is not like the other. And they would put like 4 things up on a screen, and then they would divide up the screen and they'd sing a little song like One of these things is not like the other. One of these things just doesn't belong. And then they go through the whole song, and then like they would shade in 3 of them, and one of them would be like bright. That was the one that was different. I'm hoping you guys remember this. I call this, you're like, one of these things is not like the other problem. And it doesn't really matter how you look at that to identify which one of the things is not like the other. They all tend to kind of take you in the same direction. So, for example, if you had to look at those 4 terms and make a decision, which one stuck out at you as it was not like the others, then maybe that 8BC term sticks out at you. Like maybe you looked at those 4 terms and you said like, well, that's the only one that isn't a perfect square. All the other ones are squares. Great. Well, then you become motivated to deal with the 8BC. Well, I might have some other people that would go like, no, but I think the A squared one is the one that's not like the other. Because I look at the other one and I'm used to those other 3 terms taking a certain form. Like squareds, a mixture of the 2 variables, squareds. That it really doesn't matter how you identify it. I'm hoping that we can maybe see like a trinomial here. That common form. So if you saw the 8BC as being the one that was different, then you think about that being the middle term between the B's and the C's because it shares those variables. That means the A squared's got to be off on its own. Or you view the A squared as like the one that's different, and so it's off on its own, which then drives the other 3 terms together. Okay, what we're going to do is we're going to group this 3 and 1, or 1 and 3. Now, we have a little bit of a problem if we try to factor those last 3 terms. Please don't make the mistake of looking at that and saying that that is an A squared minus a trinomial. No, it is not. That is an A squared added to a trinomial that happens to have a negative leading term. We know that because when we add negatives together, we really subtract. That if we want to view this as an A squared minus a trinomial, then we better make sure that we are subtracting that entire trinomial. And the way we'll often think about that is we're going to have to factor out that negative. So I'm going to factor out a negative from every single one of those terms in my trinomial. Notice if you expanded the blue, you would get back to the white. But now that I look at that expression factored, I'm hoping we can see that that blue expression only has 2 terms. Because of that bracket around that last trinomial is just 1 term. Okay, well, I can factor that last term because I notice that that is a perfect square. So, 2 numbers to multiply to give 16 and add to give negative 8. That would be a negative 4 and a negative 4. Now, I just want to draw to your attention that if we are in the habit of writing perfect squares in that form, I think it might come back to haunt you. That we might look at that expression and not really know where to go next. We might assume that we hit a dead end. We can see that the whole expression is not factored because I have that minus in between my terms. However, we might not know where to go. That I would hope that when we factor that blue expression, we would never write it that way. But instead, we would get very used to, if I have something multiplied by itself, then I will always write that as a squared. Because now, question F looks an awful lot like E. How many terms do I have in the red? I have 2 terms. Is there a common factor in both those terms? Nope. What could it be then? And I hope we can tell we have a difference of squares. So if I factor a difference of squares, then I'm going to factor that into conjugates. What goes at the front of both brackets? My A. What goes at the end of both brackets? My B minus 4C. And we need to make sure that we have a plus and a minus. Okay. I'm hoping that you caught what I just made in green is going to be the most common mistake that we have when factoring this expression. Like, it's so common, you probably did it, and you can't see that mistake in there. But there is a mistake in that green. I want you to notice my process again. What was squared when at the front of both brackets? What was squared when at the end of both brackets? One has a plus out in front. One has a minus out in front. And I'm hoping we can see that when I put that negative in there, I made my mistake. Notice that I am not subtracting both of the blue terms. The way that's written in that green expression is only subtracting the first. So, my recommendation to you would be, when we go through to factor this, let's go what was squared at the front of both brackets, what was squared at the end of both brackets. And because you just wrote in a two-term expression, I would recommend for you to keep brackets around those two terms. Because now, when I put in my plus and my minus, when I go to simplify those brackets, I won't forget to expand in that negative. There we go, and we like that expression. So, as I said at the outset, I think F is probably the most difficult one that we've played around with today. For us, even moving into next year, taking a four-term expression and factoring that by grouping 3 and 1 is still going to be the strategy that you're probably using least. It's going to kind of be that weird one that pops up every once in a while. So for us to kind of view that as, ooh, okay, so that one was kind of different, I think we're where we need to be. Okay, if you hit a snag on G, what we just talked about on F could have helped. However, I'm going to go through pretty quickly on this one. I just asked you to factor a 6-term expression. Yikes. But there's nothing in common in all 6. When we group now, though, I am hoping that those trinomials are just screaming at you. That we can see in the first trinomial that if we factor that, 2 numbers that multiply to give 1 and add to give 2, that's a -1 and a -1, we have a perfect square. However, given what we just talked about in F, everyone is going to remember to factor out a -1 to make sure that we are subtracting the whole trinomial. Why do we also like that? Well, because now that trinomial is going to factor into b minus c squared. And we should all be good to finish that off. So if I caught up to you on that one, I'm going to say here's a great opportunity to pause and see if you can finish off factoring G. Okay, I'm going to work our way through and finish off factoring it. So I'm going to have some big brackets here. I notice that I have a difference of squares. I have 2 terms and they are both perfect squares and there is a minus in between. So that means what was squared in the first power, what was squared in the second power. I learned my lesson. I might want to think of those as having brackets. I need an addition between one of them and a subtraction in the other one. Now we can just clean them up. And so I've got my A, and I'm just going to write it in a particular form. It's not like it's required to be in that form. When I have a multivariable expression, there really isn't a set form for what order you need to put things in. I just like to put my constants at the end. But that's me. You don't have to do that at all. And hopefully we got down to something like that. Nice. Okay. We're going to jump to our last factoring problem. I want to take a look at H because I would actually argue that I think H might be one of the easiest problems for us today. However, if I had to put money down on which one of those expressions most people left blank, it would probably be on H. Even though I think it's one of the easiest ones of the day, I'm going to bet and say that there's quite a few people that would have been absolutely stumped in what to deal with this. So don't take your maybe, complete lost feeling when you look at that expression as concerning at all. I want to maybe show you how that's really just a pretty quick grade 10 problem. I'm just going to alter something in the way that looks. That I'm going to change the way I write each of those terms. Now, I'm hoping that you can see that my blue expression is the exact same thing as my white expression. Like, they are the same thing. I know that because when I have a power raised to another exponent, I multiply my exponents. I'm just not going to write n times 2, but I'll write 2n. Now, why do I like it that way? Because maybe you can see in blue that really all I did was I gave you a difference of squares. And so if we were to factor that, then we can factor that into conjugates. And therefore, what was squared plus what was squared minus what was squared. And we're all done. Yeah, it wasn't that bad. Okay, there were 8 problems that I threw at you that should have challenged you. I'm hoping that you were feeling really challenged by those 8. The first 3 went relatively smoothly, but those last 5 are really going to challenge your decision-making process of what strategies you try to use when you try to work your way through what each expression gives you. Okay, nothing wrong with feeling super challenged today. Your job is to jump in and play around with your practice and try to make that as comfortable as possible. What I want to do is I just want to throw out a little bit of a stumper problem for people. That if this factoring starts to feel really automatic for you, then that's great. But I also want to keep you going. So let's take a look at one more problem. This last problem that I've just put up on your screen, this is a problem that I would absolutely be calling a stumper problem for us. Like, this is a doozy. For what value or values of k will that graph have no x-intercepts? And some of you guys might be looking at that going, oh my gosh, like we're getting into graphing stuff. And I'm like, maybe. But there's the problem I've posed to you. If your factoring goes super smoothly, then I'm going to argue, I think you should be pushing yourself to play around with some problem solving. Play around with this problem, see what you can come up with. However, I don't think that I would spend a bunch of time working on this problem if I was struggling through my factoring. The priority of today's topic is to make sure that we get practice with factoring. This is an additional problem for anybody who is breezing through that. So let's make sure that we've got our priorities in a good spot as we jump into today's practice, okay? You're going to see a page that's got a bunch of practice on it. Your focus as you work your way through. You want questions 1 through 3 to be pretty automatic. Okay, 1 through 3, pretty automatic. Problems in question 4. If we struggle a little bit with that, that's okay. It's okay. Problem 5, those are your doozies. And I mean, there are some in there that get pretty ugly. So, as you complete your practice today, if 1 through 3 is smooth, 4 is decent, and 5 you were frustrated with, then I would not have any concerns about your ability or your comfort level with factoring. I think you're exactly where you need to be. Okay, make the focus be questions 1 through 3. Make sure those are automatic, and I think we're good. Then just have fun with 4 and 5. Okay, best of luck in your practice.